Hi students, today let's talk about representation of sets in Venn diagram. How to represent the set in Venn diagram. Let's get in. Yeah, to represent A is subset of U. Here U is nothing but universal set. So universal set, we will take a rectangle. For universal set, to represent the universal set, we will consider one rectangle. Rectangle means that is universal set. A is a set, it is a subset of U. So A is a set. This is one set. This is inside the universal set. For example, I am taking U is a universal set. 1, 2, 3, 4. A is a set 1 and 3. I can say A is subset of U because all the elements of set A belongs to U. Then set A is said to be subset of U. How to represent A is subset of U in diagram method? Take a rectangle. This is define universal set. A is subset of universal. So inside the universal set, you are taking one set A. So set A, set B, whatever. Subsets, we will use circle to define them. So how to represent A is subset of U? A is a set. This is inside the universal set. Why it is inside? Because all these elements also belongs to universal set. For example, here set A contains 1, 3. Universal set contain 1, 2, 3, 4. This 1, 2, 3, 4 inside this rectangle. That's why this is universal set, belongs, all these 4 elements belongs to this universal set. Whereas this 1 and 3 belongs to only set A. So this 1 and 3 is a subset of this universal set. Because this 1 and 3 also belongs to this universal set. All these elements are inside the rectangle. This 1 and 3 is inside the circle. So these are the elements of set A and these are the elements of U also. Therefore, A is said to be subset of this universal set. Next, to represent two subsets A and B in universal set where A is a subset of B and B is a subset of universal set. Let's get into that. Yeah. To represent A is subset of B, B is subset of U. How to represent? Universal set, we will consider this rectangle for universal set. This rectangle is representing universal set. B is a subset of U. B is inside this universal. This is B, set B. Whatever elements are here, that is also belongs to universal set. That's why B is a subset of universal set. Now A is subset of B. A is subset of B. See now, this is set A. What are the elements are there in set A that is also belongs to set B. That's why inside the set B we should take set A. Rectangle represent universal set. Circles represent subsets. B is subset of U. That's why inside the rectangle B. A is subset of B. Inside the circle B, we should take one more circle, that is for set A. This is A is subset of B. B is subset of U. U also we can write as mu, or U also you can give a symbol for universal set. Students, in this many types are there to discuss. Let us discuss one by one. First one, in this case, this is set A, this is set B, and this is universal set. Now, if I share both A and B, means we are combining A and B, then A union B. This diagram represent A and B are combined, means they joined each other, means we are combining all the elements of set A and set B, that is denoted by A union B. Union means combining the two sets elements. So here completely shaded A and B, so we should assume elements are combined, so A union B. This A union B is also equal to set B. Look at the diagram. We joined A and B, that is A union B. A union B nothing but set B. Set B completely shaded now. So when you join A and B, we are getting B only when A is subset of B. When A is subset of B, then A union B will be equals to B. If you want, I will give one small example. If A is 1 and 2, B is 1, 2, 3. What is A union B? We will say 1, 2, 3. We need to combine. Here A is subset of B because 1 and 2 also there in the B. How to represent this in the figure? A is 1 and 2. In the place of A, I will take 1, 2. B has 1, 2, 3. Already 1 and 2 inside the circle B, only 3. Why I did not write this in the inside circle A? Because 3 is not belongs to set A. It is belongs to only set B. But this B contain 1, 2, 3. All the elements it is containing. But A contain only 1 and 2. So when you combine this A and B, what you are getting? 1, 2, 3. That means complete set B you are getting. When you combine A union B, 1, 2, 3, this is nothing but set B. 1, 2, 3, 1, 2, 3. If A is a subset of B, then when you combine A and B, we will get B set. Okay, na? Next, yeah, here this rectangle present universal set. B is subset of U because inside the rectangle B is there. A is subset of B because B inside A is there. So A is subset of B and B is subset of U. Here, if they shaded only this A part, what does it mean? This we can say A intersection B means what are the common elements from set A and set B. That is denoted by A intersection B. A intersection B is nothing but set A. Just remember the previous one when it completely shaded A union B. Now only set A is shaded, that is A intersection B. So A is subset of B. What are the common from A and B? Nothing but A. If I give example, you will get clarity. Why this is we can say as A intersection B. Let me show you. I will take set A is 1 and 2. Set B 1, 2, 3. Can I say A is subset of B? Because all the elements are there in set B. Now, what is A intersection of B? Means common elements. 1, 2. This 1 and 2 are the common from set A and set B. This 1 and 2 is nothing but set A. Therefore, A intersection B is nothing but set A. Now let us insert these elements to the diagram to understand better. A 1, 2. B 1, 2, 3. Inside the B, 1, 2 already there, only 3. So 1 and 2 belongs to A and 1 and 2 belongs to B. So 1 and 2 is a common elements for A and B. That's why A intersection B is nothing but A. This 1 and 2 not only belongs to A, it is also belongs to B. So this is a common elements for both circles, set A, set B. That's why this is a common part for both circle. That's why A intersection B. Why intersection? Because it's a common reason for set A and set B. So A intersection B. When you find this, that is nothing but A. This is second one. Again, next one more way we can represent A is subset of B, B is subset of union. Suppose if they not shaded A also, B also. That time how to represent that in the set form? Let us discuss. Yes, you are seeing here A is subset of B, B is subset of U. Now nothing shaded. Okay. Suppose they shaded only A we discussed, now nothing is shaded. So in this case, we can represent this A minus B. What is A minus B? A minus B matlab the elements which belongs to only A, that is A minus B. A is a subset of B means all the elements of A is also there in the elements of B. All the elements of set A is also present in set B. So there is no such elements present only in A. Therefore, A minus B is null set. This is nothing but A minus B null set. That means this diagram is representing A minus B equals null set. So why like this? Let me give an example. A is 1, 2. B is 1, 2, 3. Condition is A is subset of B. So here A is subset of B because all the elements are there in the B. Okay, find now A minus B. What is A minus B? The elements belongs to only A. One is belongs to both. Two also there in the both sets. There is no such elements which is belongs to only A. Therefore, null set. So this Venn diagram representing A minus B is null set. So next, both shaded over, only this inside A shaded over. Now both also not shaded over. Next, if only this part shaded, how to represent that? Let us discuss. Yeah, here this shaded part, how we can represent this Venn diagram? If you look at very carefully, this is the shaded portion belongs to only set B. They are not belongs to set A. Therefore, this I can represent B minus A. What is B minus A matlab? The elements which are belongs to only B, not A. So this region where I shaded this part, this region belongs to only set B, not for set A. That's why B minus A. So how can I represent this Venn diagram? Means B minus A. Next, let us take two subsets. If they intersecting, two subsets when they are intersecting inside the universal set. Okay. Yeah. To represent two intersecting subset of universal set. So I can take one rectangle. This represent the universal set. One set I am taking A, it is subset of U because it is inside the rectangle. Another subset I am taking B, this is also subset of U because B is where it is inside this rectangle. So B is also subset of U, A is also subset of U. But these two are intersecting. These two sets are intersecting. A is subset of universal set. B is subset of universal set. Both A and B are intersecting. In this, how to represent in a different ways when they shaded these complete parts, only this part, only this part, only this part. Other than these three remaining part, let us discuss one by one. The first one, is subset of U, B is subset of U, both are intersecting. Here shaded region, if you see, you may understand, completely A and B combined. Therefore, this we can represent A union B. This we can represent as A union B, because these two regions completely shaded, means A and B combined. Therefore, A union B. Suppose only this part, if it is shaded, how to represent? Let us discuss. See here, if they shaded only this area, how to represent this in a set form? Look carefully. This is a region belongs to bangle A and bangle B, means circle A, circle B. It's a common region for both set A and set B. So common region means A intersection B. Okay, this is a common region for A and B, means A intersection B we can say. When it is completely shaded, A union B. When this space is common for these two, then we can say A intersection B. Next, you may think, sir, only this area is shaded. How to represent that? Yeah. If you look at this shaded region, you may understand this region belongs to only B, because this region completely belongs to A, but shaded part belongs to only B. The elements belongs only B, not A. What we will say? B minus A. What does it mean? The elements belongs to only set B, not A. So this region belongs to only set B, not A. So this diagram represent B minus A. Next, you may think, sir, then if this part only shaded, not these two, let us discuss. Yeah. Here, this shaded region, if you look carefully, this is belongs to only A. It's not belongs to set B. The elements which is belongs to only A, not B, we can define like A minus B. The elements belongs only set A, not B. That is nothing but A minus B. So next, we may get another doubt. Sir, don't shade these three parts. Shade other than this. Then how to represent that in a set form? Yeah. See here. Completely A and B not shaded. Other than that, from the universal set they shaded. Just recall what is complement. Suppose U is 1, 2, 3, 4. A is 1, 2. What is A dash? Other than this 1 and 2, which are the elements left in the universal set? 3 and 4. This is A dash. So this concept I will use. Other than the elements of set A, which are the elements belongs to universal, that is A complement, A dash. Here, what is A union B? Means combine both set A and set B, we need to combine. So these two, A and B, when you combine, you will get this unshaded part. But we don't want this unshaded, we want shaded. Leave these, take complement. What does it mean? Other than A union B, which are the elements from the universal set, that is complement set. What is A complement means what? Other than A, which are the elements in the set U, that is A dash. B dash means other than B, which are the elements left in the U, that is B dash. But we are not talking about only single set. Now we are talking these two. What is these two? A union B. Other than that, we shaded. Means other than that means this part belongs to U. Where we shaded, that part is a region of universal set. So A union B we don't want. Other than that, in the universal set, other than means complement. A union B whole dash. This complement means leave that remaining in the universal set. That is A union B whole dash. Next, one more doubt will arise. What is that? Sir, suppose you shade these two areas, leave this area, then how do you represent that in set form? Let us discuss. Yeah, look here, this space not shaded. How do we represent this? It's a common place of A and B, therefore A intersection B. We didn't shade this. Other than that, in universal, we shaded. Other than this means complement. Got it? A intersection B not shaded. Other than that, in the universal shaded. So A intersection B whole dash. Whole dash matlab complement of that. Leave the common elements other than that which is belongs to universal, that we need to take. That is A intersection B whole dash. Okay, na? So next, let us discuss how to represent two distinct set in universal set. Okay. Yes, students. Here, two distinct set we need to take inside the U. I have taken one rectangle. This rectangle represent universal set. Distinct mean they are not intersecting. This is A, this is B. Two are distinct, different elements they have, but they both are inside the universal set. Now we need to talk about this type of diagram comes means how to represent. Sometimes both may be shaded, sometimes only A can shaded, sometimes only B can shaded. Let's discuss that. Yeah, first one, if A is shaded, how to represent? You need to use this A and B. Only A shaded means the elements only belongs to A, not B. How do you represent that? A minus B. And the elements only belongs to A means that is A minus B. Means because A only shaded. This is nothing but A minus B. A minus B is nothing but, you look at this, which set is shaded completely? A. A minus B equals A when A and B are disjoint. There is no common. In this case, A minus B is nothing but A. There is no common means only A. Next, if it is shaded only B, in this the elements belongs to only B, because B is completely shaded means the elements only belongs to B, not A. In this case, we can say B minus A. B minus A is nothing but shaded part, you see, that is completely shaded B. So it is equal to B. B minus A means the elements belongs to only B, not A. So B completely shaded. So B minus A will be B when A and B are disjoint set. Okay. Next, you may think, sir, both are shaded. Now, both are shaded means we need to take A and B together. That is nothing but union. A union B. Another doubt will arise. Suppose both are unshaded, sir. In such case, how to represent that? See now, here both A and B set are unshaded and they are distinct. There is no common. We are not combining. So in this case, how to represent? You cannot use union, but I can say intersection. Sir, both are not intersecting. There is no common. Then why you are using this A intersection B? Wait. A intersection B is null set. This I can say. Because there is no common, so null set. Okay. Now next, let us discuss how to represent three intersecting subsets of universal set. This is there in the class 10 also, and reasoning class also. In when you this year only you may have this sets in reasoning class. It will be useful there also, and class 10th also in reasoning class, NTSC class. Okay, let us talk about that. Yes, to represent three intersecting subsets in universal. Let me take one universal set. This rectangle represent universal set. Three subsets we are taking, which are subsets of universal, and they are intersecting each other. Circle A, circle B, circle C. All these three circles are intersecting each other. They are subsets of universal set because all are there inside the rectangle. So all are subsets of U. Now, first case, if all shaded, how to represent? We are combining all the elements. Therefore, combining time union. A union B union C. Suppose only this part shaded. How to represent that? See now. A, B, C all are intersecting. This part they shaded. How to represent? Look carefully. This is the region belongs to A. This is the region belongs to B. This is the region belongs to C. So this is a common region of A, B, C. Three circles. Common means we should take A intersection B intersection C, because it's a common region for three circles. Okay. Next, one more doubt will arise. What is it? I will show. See the diagram. Here, how to represent this in set form? If you see this, A completely shaded, so I should take A. For that, this shaded part is included. So that include means union. A completely shaded, so I am taking A, and this part is also included, so union. How to represent this part? This is the region belongs to only B and C. It's not belongs to A, remember. This is the region between only B and C. It belongs to only BC. This belongs to only AC. This region belongs to AB. So this is nothing but common region for B and C. Therefore B and C common matlab intersection. So this is how we can represent this shaded part. Then another type. Here we need to represent this shaded region. Listen, B and C completely shaded. What we will say? B union C. Okay. Now one more set, that is A. But this is not completely shaded. If it is also completely shaded, again I can take. B union C means completely B and C shaded. But A also taken, but it's not completely shaded. So listen here. One second. Let me explain with this diagram. B union C means completely shaded. B and C completely shaded. B union C. If I take one more set A, what are the parts belongs to A? These three parts belongs to A, and these three parts belongs to B union C. But these three parts is a common for A and B union C. These three parts, let me show. B union C means all I will shade, including this, that is B union C. And these three parts belongs to A, and these three parts belongs to B union C, but not complete B union C. Okay, if you assume B union C and A, this is the part belongs to A and belongs to B union C, but not completely B union C, so that it's a common part. These three are common part for A and B union C. Okay, if completely shaded, this means directly I can write B union C, but here it is the common part for A and it is common part for B union C. So A intersection B union C. Understood? Some notes are there that we need to discuss. Okay.